err is human. Consider a situation where you're writing a self-closing image tag in HTML and you forget to put a / before the closing angular bracket in order to close the tag. While using HTML, the code might still work on some browsers, but while using React, you are not allowed to make such mistakes. How do you find out such errors? In a small application, you can definitely spend some time and find all the errors and reduce the chances of potential bugs. But what if the application is too large to do it manually? This is where a linter, or simply what you call a lint, comes in. A lint is a set of tools that analyze your source code to flag programming errors, poor coding styles, stylistic errors, and bugs. Even though modern compilers have evolved to include many of Lint's historic functions, Lint-like tools have also evolved to detect even wider variety of suspicious constructs. One such lint is ESLint, which provides linting utility for JavaScript and is being commonly used by React developers. I believe that practical knowledge is important to understand how things actually work. It leads to a much deeper understanding of a concept because you experience it on a personal level. For example, if I just explain to you how to drive a car while telling you the parts of it and when to use which part, you might understand how a person drives a car, but you will never be able to drive it yourself. You can't do it unless you actually attempt and learn how to drive a car by yourself. Similarly, in this module, I will be taking you through practical examples while explaining to you different concepts of React. These examples will actually be aimed towards building a small application that we'll be making together while learning React. The application that we'll be building together will be a single-page application. Before jumping into knowing about what a single-page application is, let's first see a multi-page application. An MPA, which stands for multi-page application, consists of several pages with navigation to other pages embedded into it. When you move from one page to another, the browser reloads the content of the new page completely and downloads all the resources again, even if the components are being repeated throughout all the pages. One such example can be the header of an application. In most of the applications that we see, the header remains constant across the web pages. If you build a multi-page application, this header would be re-rendered in all the pages, which is ideally not required. On the other hand, a single-page application works on the browser and does not require a page to be reloaded while being used. You might be using single-page applications every day. Some of the notable examples are Gmail, Google Maps, Facebook, GitHub, etc. SPA, an acronym for Single Page Application, is lighter and faster in comparison to multi-page application just because most of the resources are being loaded at once for the lifespan of the application. Only the data is transmitted back and forth. Single-page web applications fit perfectly for building dynamic platforms with small data volumes. A single-page application is excellent for social networks and closed communities which require good application performance, dynamic nature, and user experience.